My name's Tom. I'm a tutor of the Oxbridge Group, and today we're going to be doing a session that should help anyone applying for doing geography at either Oxford or Cambridge. Questions will specifically focus on ecology and biodiversity, which are some of my specialities as an undergrad when I was studying geography at Oxford. So the following slides, each one will contain two images taken from Google Earth comparing two different areas of the Earth's surface. And for each one, what we're going to do is judge using the resources we have to determine which one we think will have a higher level of biodiversity. So while doing this, it's important to keep in mind both the why and the how of what we're doing. So first of all, how are we defining the terms of a question? What do we mean by biodiversity? So the very simple answer to that is the number of species located in an area. For simplicity's sake, it's the definition that we're going to roll with in this session. But as we'll see later on, there are different versions of the definition we can use, and these can complicate our answers to the question. And another important one to take note of is the why as well. What are the bigger questions we're dealing with while answering these questions? So, for example, the relevance of biodiversity conservation, issues like that as well. So, getting started. First two images, the one on the top left shows the Peruvian Andes, and the one on the bottom left shows the central Amazon rainforest located in Brazil. So, if you pause this video, then just go over two images, pick out what you think some key differences are, and from that, judge which one you think will host a higher level of biodiversity. Hopefully, you've noticed the main difference between these two images. So, the one on the top left is clearly a much more mountainous environment than the one on the bottom right. And it is true that more mountainous environments generally support higher levels of biodiversity. So, if someone was to ask me, I would say the image on the top left shows more biodiversity than the one on the bottom right. So, right now, maybe it's worth pausing the video for a little bit and thinking about why that might be. So hopefully you've had a chance to think about that. So the main reason is that areas with a greater degree of elevational diversity, by which we mean essentially more very high areas as well, more very low areas, support a much larger range of climate zones. So you can see in this image, these sort of brown areas where the mountain peaks are, there isn't much vegetation coverage, and the habitats here will be very different to what they are in the valleys, which are much more forested. So these areas having very different habitats will support very different kinds of plant and animal species than the areas in the valleys. So here we can see essentially that in very small areas, if you do have an elevational diversity, you can have a very large range of ecological communities co-occurring in small areas. And another point to note is that an area being more green doesn't essentially mean it's more biodiverse, which might have been a trap that some of you fell into. So this bottom right image, obviously it will be a very biodiverse area, same from the Amazon rainforest. But it's often a misconception that simply having a great degree of plant coverage or even having a great degree of plant biodiversity doesn't necessarily mean you'll have a great degree of animal biodiversity compared to areas with much more greater topographical diversity, like this image on the top left. Here we have two more images. Both of these are taken from environments that have a significant degree of human interference in them, at least compared to the former two. So the one on the top left is of a palm oil plantation in Borneo, and the one on the bottom right is of agricultural land in northern France. This image was taken just north of Paris. So if you pause this video, have a think about which one you may think may host a greater level of biodiversity. Not just plant biodiversity, but animal biodiversity as well. Someone's asked me what the answer to that question would be, I would say the one on the bottom right is more biodiverse. This is primarily because we can see the one on top left is what we call a monoculture, which means it contains virtually one species of plant, in this case that being palm oil. The one on the bottom right we can see has quite a large variety of landscape diversity. So we can see that there is fields used for crops and the like, but there's also areas of woodlands, hedgerows as well. So this variety is quite important to supporting local biodiversity. Hedgerows in particular have been noted in England as being a really key feature for preserving bird species. They kind of provide these little pockets of habitat in between agricultural land which species can live in. So think about why is it that monocultures don't provide this level of support to more diverse biological communities. And the reason for this is that effectively, if you only have one species, that single species can only support a very small number of species. It only provides a food of a habitat needed for a very certain amount of species, compared to one on the bottom right where you get a large variety of habitat diversity. that can in turn support a lot more species with a lot more different habitat requirements. But an important thing is to note is that can agricultural land, which both these images show, can these areas ever be truly biodiverse? Obviously, in the Anthropocene, this age we're living in, where human influence on the planet is becoming incredibly varied and strong, is it possible that we can make agricultural land suitable for supporting diverse communities of wildlife? Or is it simply that while some may be better than others, they still do diminish these communities to levels of unacceptable low biodiversity? This should hopefully get you to think about why we're asking these questions about biodiversity and habitat variety. These are massively relevant questions to current issues of conservation, and it's a good thing to think about when you're planning for your interviews as well, because they will try and ask you questions that are very relevant towards modern world and how geography is relevant towards modern policy making. For our final image comparison, we've got a bit more of an out there one, and hopefully this one should help you think more about what exactly we mean by biodiversity and why exactly the contested nature of these terms matter. So the top left image here is a screenshot of London Zoo in Regent's Park in London, and the bottom right is of Yellowstone National Park in the USA. So obviously the image on the bottom right is of a far larger area. However, in London Zoo, there are over 70 mammal species housed here, and in Yellowstone National Park, there's around 67 mammal species, that are found to occur in this area. So I want you to think, obviously we know there are more mammal species in this top left image than in the bottom right, but would you consider this diversity of species in the top left to be true biodiversity, whatever that may mean, whatever you think that may mean, compared to the bottom right? So if you pause this video and have a think about that. If you was to ask me this question, I would say that applying the concept of biodiversity to an area like London Zoo is effectively a bit of a useless exercise. And the reason for this is that there's no ecological community and there's no ecological interactions occurring within this environment. So there's no predator-prey relationships, there's no reliance between species on each other for habitat or food. So to try and compare an environment like a zoo to a non-managed or at least minimally managed area like Yellowstone National Park, they're kind of incomparable. So this does raise a question of why is the presence of functioning communities and ecological interactions key to defining biodiversity? And I argue the reason for this is that effectively you need these interactions to support species. Species do rely on each other for this kind of support. So, for example, in the case of a palm oil plantation we were discussing before, the reason an area like this, a monoculture, would have low levels of biodiversity is that only having one species means it can only support a very minimal number of additional species through providing food, habitat, that kind of thing. So it is through the ways in which species provide these resources to other species in which high levels of biodiversity come about. Hopefully, what should be becoming obvious here is that when we're using the term biodiversity, it's not necessarily always an objectively used term. Within the field of geography, what we're doing is taking non-human concepts and applying human interpretations to them. So the term biodiversity itself is a way that we can interpret a certain phenomena we've observed in nature. So this should kind of raise questions of, do biodiverse communities always need to be wild, and what does the term wild even mean in this case? And at what level of human interference does biodiversity cease to be natural? What this example I've used here should hopefully show is that using the term biodiversity in its most simplistic terms, simply being the number of species found in an area, cannot convey the complexity of the diversity of a way in which ecological communities occur. And this is, of course, especially relevant for the modern age when human influences on our environment, on non-human animals, are so great that it's becoming increasingly difficult to distinguish between environments we consider to be untouched by humans and to be touched by humans, if that distinction is even a thing that we can still make. A really important skill to be able to have when conducting interviews at Oxford and Cambridge is being able to interrogate the terms of the questions you're being asked and to kind of challenge the sort of fundamental assumptions that are happening here. So in this example, we're really taking the concept of biodiversity and asking, is it still a useful concept for the present day? And if the answer to that is no, then in a minute we'll come on to some other examples of how we can challenge this idea of how we define biodiversity and see some other examples of how it can be defined. I mentioned before, it's always very important to interrogate the terms of a question. And as I mentioned before as well, there are different ways that we can define biodiversity and apply different definitions to the examples we've done before. So in the PowerPoint, I've included a link to a blog that I found quite useful and includes definitions of what we call alpha, beta, and gamma diversity. So these are three different ways of defining biodiversity, each with a different focus. So, for example, the term alpha diversity refers to the very simple notion of how many species are within a certain area, and the term beta diversity refers to how distinctive that assemblage of species is to the area surrounding it, so how unique that specific area is compared to those surrounding it in terms of the ecological communities that are found there. So hopefully you may find it useful to read up these terms, get a good idea for how they're defined, then go back over these examples with views and critically reevaluate what your answers to them have been. What you may find doing this is that using different definitions of biodiversity may change which areas you consider to be the most biodiverse. And in addition to this as well, you can also think about the ways in which using different definitions of biodiversity, the ways in which this has different implications for conservation policy, and the way that we manage the decline of biodiversity in the wild. So, for example, if we were to say establish a protected area to protect a certain number of species, how would we decide which area we protect based on which is most biodiverse and which definitions would be used to reach this conclusion? Another important topic to consider is how we've got information as well. So geography is a science, and the way in which we convey information and gather information is very important. So here we've been using vertical satellite images showing different areas where we've been judging levels of biodiversity. So it might be useful to think about how effective do you think these tools were in showing that. Also as well, what certain aspects of ecology or biodiversity may be hidden by the use of vertical images. So, for example, a key feature of what drives high levels of biodiversity in the rainforest is a structural variety of trees. So, if we're only able to see the top canopy of a rainforest using satellites, does this perhaps disguise our ability to see the true levels of plant variety within forests and from that infer the level of biodiversity? So, hopefully, you found this a really useful for exercise for approaching geographical issues in a more critical way. Um, I've tended to found that this approach is very useful for interviews because it kind of shows the students able to approach issues from a different perspective, and of course is able to challenge the terms that they've been taught and think about issues in geography such as biodiversity in a very different way. So any official information on the interview process or on, say, mock questions can of course be found on the websites for both Oxford and Cambridge's geography departments. This has just been, a way to show you as a student of geography at Oxford how I found to be a useful process for approaching these questions critically. And hopefully you've learned something useful today. So thank you.